statement like number 23. And we're going to have a limit as x approaches infinity of x over x squared plus 1. And as you see, this is a first degree polynomial, monomial actually, but a monomial by definition could be considered a polynomial if 0 added to this, or whatever. And this is x squared, this is second degree, first degree, second degree polynomials. So we know that this is going to be the first of those three guidelines that we were looking at here. The largest value we're going to get here is we're going to divide divide by x squared, the same as multiplying by 1 over x squared. And if we do that over here, then I'm going to have to put that to the top as well to keep this fraction equal. Okay? So this is going to become 1 over x over 1 plus 1 over x squared. Now again, x is approaching infinity. So if I plug in infinity here, I have 1 over infinity, which is 0. 1 over x squared is 0. 1 plus 0 is 1. And this gives me 1 over 0, which is 0. And that's exactly what that first guideline told us. That if your degree on top is smaller than the one on bottom, your limit is going to be equal to 0. Number 25. This is the limit as x approaches negative infinity. Okay, that's going to be important here. But initially it's not going to be important because we're going to calculate the same way we did this up here. So this is 5x squared over x plus 3. Okay, so now we have, this is the third part of the guidelines they gave us, where the numerator has a larger degree than the denominator. This is second degree, this is first degree. So we're going to divide by x squared and multiply 1 over x squared for both of these. And so this gives us 5 over, and this is going to be 1 over x plus 3 over x squared. And again, x is approaching negative infinity. That gives us 0 there, that gives us 0 there, that gives us 5 over 0. But because we are looking at the negative infinity side, instead of putting infinity down, this is going to be negative infinity because it's approaching that. It's going to the left instead of to the right. So there's our negative infinity. Had it been from positive infinity, that would have been positive infinity. Just like those two wings we had in the first graph. The left wing is the negative infinity, the right wing is the positive. 27. This is a good problem. So we have the limit as x approaches negative infinity. The value for this is x over the square root of x squared minus x. Now, we have to kind of view this radical from an x to the 1/2 power sense. So the degree of this is 1. The degree of this, the highest exponent inside the radical, is squared. But because this whole thing is being taken to the 1/2 power, this is technically a first degree because 2 times 1/2 is 1. So that's a first degree polynomial. So we should get some kind of ratio out of this. Now, of course, things are all screwy here because of the radical here. But what we do know is, excuse me, we're going to multiply the top by 1 over x. Now we have to do the same thing with this. So what I'm going to do is, because of this is going to negative infinity, I'm going to put this on times 1 over a negative square root of x squared, because we're going in the negative direction. Okay? So that means this is going to be inside this radical now. This is going to create this scenario here. This is 1.5. So both of these denominators are going to be, actually this is not going to go inside. You can't have that in there. This is actually going to go on the outside here. When I resolve these two right here, I'm going to get a negative value of whatever this turns out to be. Well, we know that x over x is 1. So we'll put a 1 over there. And then this is going to be negative square root x squared is 1, x over x squared 1, and negative x over x squared is negative 1 over x. And as x approaches negative infinity or positive infinity, either way, that's going to equal 0. So this is going to be equal to 1 over, that drops out, so that leaves us negative 1. So the answer here is negative 1. So we got to be careful of that. This sign makes a difference, and the radical makes a difference in problems like these. Last one I want to do. Number 31. Throw a little trig in here on you, just because we love to. So this is the sine of 2x over x. Okay, and this is, probably should have written this down, sorry. Got a little ahead of myself here, we're going to write the problem down. The limit, as x approaches infinity, sine of x over, or sine of 2x over x. Okay? So, we're going to be looking at the limit of sine of 2x over the limit of x. Now, in this kind of a scenario here, we're going to be looking at the range of possibilities for the sine of 2x. Now, we know that sine of x and the sine of 2x, sine of 3x, sine of 5x, they all have the same range. It's from negative 1 for a minimum to a positive 1 for a maximum. Okay, so what I'm going to, since we're looking at the limit of this whole thing, I'm going to put down negative 1 over x. Negative 1 over x for this, and that's going to be less than or equal to the sine of 2x over x here, because it's going to be somewhere in between these. It's going to be less than 1 over x. Okay, now, since I'm putting infinity in here for x, again, that means then that this is going to be negative 1 over infinity, which is 0, is less than or equal to, and this is going to be, well, let's take a look over here. I'll show you the symbol here. 1 over x is 1 over infinity, which is 0. And so this value right here is going to be between 0 and 0. What could it possibly be? Answer is 0. And there is your limits problems. Your assignment, page 205, 22 to 32 even. Do not do number 30. Have fun.